This question belongs to electrochemistry chapter. The standard cell potential inert cell of a fuel cell based on the oxidation of methanol in air that has been used to power television relay station is measured as 1.21 volt. The standard half cell reduction potential for oxygen inert O2H2O is given, which is 1.229 volt. So we have to choose the correct statement. So now here fuel cell basically it means it is a cell where you will continuously supply fuel and you will continuously get the electricity. So it is not just like battery and fuel cell, these two are different thing. Battery is the conventional cell and fuel cell is different thing. Means here you have to continuously supply fuel. If you continuously supply fuel, then continuously you are going to get electricity. So this is the difference. So now we have to verify all of these four options. We all know inert cell equal to inert cathode minus inert anode. Standard cell potential is given, which is 1.21 volt equal to inert cathode. At cathode reduction happens. So from the question already we have this data that standard half shell reduction potential is given, that is 1.229. So half shell reduction potential will be 1.229 volt minus inert anode. Now if we solve this, we will get inert anode that comes 0.019 volt, which is 19 millivolt. Statement 1 is correct. The standard half cell reduction potential for the reduction of CO2 is 19 millivolt. In this particular fuel cell, actually we are supplying methanol as fuel and as byproduct we are getting CO2. Now check statement B. Oxygen is formed at the anode, which is not correct. Why? Because at anode oxidation happens, right? At anode oxidation happens, and oxidation of what? Oxidation of methanol, CH₃OH. Since at anode oxidation happens, so oxygen is not formed at anode. So statement B is wrong. Reactants are fed at one go to each electrode. No, we have to supply reactant continuously. It is not at one go. So that's the definition of fuel cell. Here we have to supply fuel continuously. Statement C is also wrong. Reduction of methanol takes place at the cathode. No, oxidation of methanol is happening at anode. So statement D is also wrong. So for this question, statement A, that is the correct one.